We're going to go over a chapter that deals with the time value of money. This is a very straightforward chapter. We're going to spend a little time in this. This should be a very enjoyable part of a lecture. Well, for a few reasons. I mean, honestly, you guys should have been introduced to the time value of money in other previous prerequisite courses. You should probably see it in finance. You may see it in another accounting course or whatnot, maybe economics course. But you should have an idea. So I'm just going to briefly touch on the time value of money and how it applies to financial statement purposes for a certain aspect, which you will learn later down the line in a series of other lectures. So basically, here's the whole idea about the time value of money. A dollar today is worth more than a dollar tomorrow. And there's several reasons why. I mean, two of the main reasons you can understand is the power of a dollar today. If you talk about inflation, we'll naturally have more of a buying power than a dollar tomorrow. If you assume that inflation is a natural event that normally occurs through time. If you don't consider inflation, then you could easily defend that a dollar today is more than a dollar tomorrow because of the time value of money, which deals with interest. Anytime you have interest applied to something, you have an opportunity to receive a capital gain on that particular initial amount. And so basically we're saying a dollar a day is more important or more valuable now because I can invest it. I can get some type of interest on it. And so we're going to look at the ways in which interest can occur and how does it capitalize with time. In theory, the longer the time something's being invested with an interest rate, the more you should have. And so there are basically two quick concepts. I'm not going to go too much in depth with this because you guys are going to read this anyway. But there's simple interest and there's compounded interest. And we're going to focus more on the compound interest side. But simple interest is basically saying that the interest will be applied on the initial investment once, just one time. So whatever that one time is that it occurs in that year, that's the amount that the interest is going to be invested on. And the following year, simple interest basically saying that that interest for the following year will still occur on the principal. That's simple interest. It's always going back to that initial amount. So if it's a dollar and you have something for 3 years and the interest rate is 10%, obviously that's 10 cents every year that's going to be applied to the dollar. That's simple interest. In contrast, we talk about compounded interest. This basically means that interest compounds on top of interest itself. So interest builds interest on top of itself from a compounding aspect. So if you have 3 years of an investment, $1 invested, and it's 10% interest compounded annually, well, this simply means this. The first year, obviously, you're going to get 10 cents, right? What's going to happen to that 10 cents, which is the interest for the first year? It goes into the principal. So now your principal is no longer a dollar. It's $1.10. So the following year, when it's time to apply that 10% interest, it won't go on a dollar anymore. It's going to go over the compounded interest, which is $1.10. So now you have 10% of $1.10. And as you can see, it keeps getting bigger and bigger and bigger. So for this particular purpose of this lecture, we're going to talk about how to calculate the present value of a single amount. We're going to talk about how to calculate the future value of a single amount. And we're going to talk about how does that take into effect if interest is compounded more than once. Okay? And so I just want to kind of go over some problems. I think it's easier with this particular chapter to just go off with some problems and you learn as you work the problems. Okay? So the first problem we're going to deal with deals with how to calculate the future value of a single amount. So if we invested into something at a particular time and we had some type of interest added to it, we can calculate what that amount would be at a particular time frame based on the future value of a single amount. So there are 3 ways actually that you can go by calculating this. I think for this lecture, I am going to go into 2 of the 3. I think I'm going to let you do your own due diligence and invest some time or maybe provide you with a link to show how to do the 3rd one. So basically the 3 ways are as follows. You can calculate the future value from a good old-fashioned calculation, a manual calculation of a formula. You can use a particular chart that is given in the back of the appendix of the textbook, or you could use a financial calculator. Now, unfortunately, of the 3, I use financial calculators. I didn't really bother to try to memorize the formula that much when I was in undergrad, and I didn't care for using the charts. I just went straight to the financial calculator. So it's a good tool. But I won't be sharing you how to use a financial calculator because this is an online course and several of you guys have different types of financial calculators, okay? And so what I would do is if you choose to use a financial calculator, I would suggest that you go to YouTube and you type in time value of money example with whatever financial calculator you're using. It has to be a financial calculator. So basically with this example, it wants us to calculate a future value of a single amount, okay? And so I'm going to give you 3 different single amounts. Let's say the first amount is going to be 15,000. Let's say, yeah, it's 3. Second amount is going to be 20,000. And the third amount is going to be 30,000. So these are actually the current amount invested. The current amount invested, we're going to call this the present value, PV. Why is it the present value? Because this is the current amount of the value of the investment, the present value. Next, they have to always give you an interest rate. So let's give some interest rates for this. First interest rate will be 6%. Next interest rate will be 8%. And the last interest rate will be 12%. And then the next component will be the time, right? The time. So we're going to talk about the number of years. So we're talking about the number of years. And we're going to say 12 years. We're going to say 10 years, and we're going to say 20 years, right? And so the object of the game is to calculate the future value. So basically for this example, we have $15,000 right now. And if we were to invest that into something that would give us an interest rate of 6% annually, which means that at the end of 12 months, it's going to apply a 6% interest rate. And let's say we hold it for 12 years, how much will we have? And remember, this is dealing with compounded interest. And so basically every year, that principal amount grows based on the previous year's interest that was applied. Okay? So let's talk about the formula, the good old-fashioned formula. Future value is equal to present value times 1 plus the interest rate of the times the quantity 1 plus I to the n power. So it's the present value times the quantity 1 plus I to the n power. Okay. PV obviously means present value. You guys already know that. I stands for interest rate. And N, of course, is going to stand for number of periods. Number of periods. FV simply means your future value. This is what we're trying to calculate. So I could easily use this formula, guys, if I choose to, right? We have 3 ways to do it, but this is the formula way. So what I would do is take the present value of 15,000, multiply times the quantity 1 plus I. The interest rate is 6%. So therefore, we need to convert that into decimal to keep everything the same. So 0.06. And of course, we have the nth power, which represents the years. The periods are years in this example. So we raise it to the 12th power. Okay? Now, rule for thought is that you should always apply your order of operations. So your exponents need to be raised first. So we're going to take 1.06 and this calculator. We're going to raise it to the 12th power. And that's going to equal 2.0121. I normally go 4 decimal points over. That was just something that was always training me in B school. And so we take that number, right, and we multiply it times the 15,000. And this will give us our future value, right? So 2.0121 times 15,000 gives us something of $30,000, 181.50, right? And so basically we're saying if we started out and invested $15,000 into an investment that gave us 6% interest and we held it there for 12 years, we would pretty much double our money. Okay, so this is the first alternative way that you can use the old school method, which is the formula. Okay, let's look at another way in which we can find the correct answer. The other way would be to use the chart in the back of the book, right? And what the chart in the back of the book does is it gives you the interest factor that's needed. And if you have the textbook, the correct textbook is literally in the back of the book, the very last pages. And it should look something like this, right? See? Book. Something like that. Very last back of the pages. And so basically you have several of these. You have a few sheets, but you have to make sure you're looking at the right one. And right now we're trying to calculate future value, so we would consider the very first one in the appendix, and it's highlighted as a title in a table of Table 1, Future Value of $1. And they actually show you the formula right there. But instead of having to apply the formula, we're going to use this table. And if you look carefully at the table, we have rows and we have columns, right? So we have rows and we have columns. If you look at the column titles give you the interest rate that you need. If you look at the rows, the row title will give you the period, right? So I'm going to try to zoom in on this. The lighting is horrible in here, but we're going to make it work, right? So something like that, okay? And so easily what I would want to do is, based on this, what I would do is I would look for the interest rate, which is as is 6. So I would look in the column of 6%. Then I would scroll all the way down to 12, right? So I scroll all the way down to 12 at 6. And I get 2.01220. That's my interest factor, 2.01220. Should be almost the same thing as the calculation that we've done. Once you get that interest factor from your chart, you would easily just multiply the 15,000 times it. And that will give you the future value. Really, really easy. And of course, if we take the 15,000, multiply it times 2.01220, we get 30,183. And it may be off a few cents, but at this point, who's counting? This is where we're going with it. And of course, if it is off a few cents, it's because of the rounding of the decimal. Okay? So those are two alternative ways that you can utilize to calculate your present value and your future value. Okay? Basically, I guess we could do one other one just to make sure that you guys understand. But of course, the cool thing about this is a video, so you just can rewind it if you don't understand, honestly. And so we can quickly do the second one. The second one, if we want to use the formula, we know the formula is present value times 1 plus I to the n power. Present value being 20,000, the interest rate being 1.08, and the number of years is 10. Again, we have to always consider the interest factor, which is raising order of operations, 2.1589 times 20,000. And of course, 2.1589 times 20,000 gives us 43,178. So 20,000 for 10 years, 8% interest, you more than double your stuff. Not bad. Not bad at all. All right. And of course, if we wanted to do it the other way, right? If we wanted to do it the other way, we would simply look at the same table. We would look at the 8% column, and we will scroll all the way down to the 10-year, and that gives us 2.15892. Take that number, again, multiply it times the 20,000, and that will give you your future value. 2.15892 times 20,000. Again, future value, 43,178. $4. Okay? Pretty straightforward.